The project manager creates a new task for the facade production engineer to investigate multiple facade assembly simulations comparing a tower crane with a mobile crane. To start off, the production engineer reviews the building model with the individual facade panels, each with their detailed components organized in the assembly model. They open the existing Delmia PPR structure with the building referenced in, along with the MBOM and the operations necessary to start the first simulation. A new branch is created for scenario 1 from that existing Delmia PPR, and we view it in the Innovia Collaborative Lifecycle app. They launched the Delmia Assembly Evaluation app to start the first assembly simulation track on the operation of the first panel. They start this by moving the panel in position and recording each location and orientation as they go along, simulating the motion that the panel would travel if carried by a tower crane. Once they have it in its final position, they save the track so that it's ready for replay. They can control the speed of the replay so they can run it back faster and examine how it would be put into place. The facade production engineer wants to explore how to create these tracks automatically. So they opened Exgenerative Design model. In this model is defined the panel locations and types as access systems. And then they've defined a series of tracks within Exgenerative Design, which are visualized, showing the start and the beginning of each track. The final output from Exgenerative Design is a list which includes the panel name in order and all the access systems as a string, which will be interpreted in the final model. They return to the PPR context and open the EKL action script that will automatically create the tracks from the Exgenerative Design input. Once the script is launched, inputs are selected, including the building model, the MBOM, and the operations, or the means and the methods. And then we select the published list from Exgenerative Design and run the script. The result is a tailored track for each of the 180 facade panels. Now we can look at each of these tracks in the Gantt view and see the duration of each of them. They're constrained and how they vary as the lifting distances vary. They can play the whole scenario back in normal speed or sped up and examine the entire scenario as it would play out. The production engineer has posted both the tower and mobile crane scenarios as ideas in the community. The project manager reviews the tower crane scenario to see how that one would be played out. And then the mobile crane scenario, looking to see that there be significant time savings. As the video of the assembly simulation was reviewed, it's decided that this is the one to advance to the next stage, both because it saves time and doesn't utilize the tower crane. The facade designer dynamically changes the form of the facade per the client request for visual interest and shading. A rippling surface is created from a custom branching pattern in Xgenerative Design. The building model in CATIA is updated, and each panel now has the input surface from Xgenerative Design incorporated automatically. The production engineer accesses the mobile crane scenario, which has the building model automatically updated inside of it, requiring no rework. A manufacturing simulation is set up with interference probes and the tracks included in order to identify any potential conflicts in the assembly simulation design. The production engineer can see that there is a clash and identify it right away. They can see also how the clash plays out in the animation of the simulation. The project manager reviews a 3D issue created by the production engineer about this conflict. They can see first in 3D within context where this issue is taking place. And then they can examine within the issue itself a video and images that highlight this conflict. Right away, they can provide a comment back and say that they look at other scenarios lifting from the roof. In addition to a scenario with a mobile crane lifting from the roof, the production engineer looks at incorporating two mobile cranes. They look at the order of the panels in Xgenerative Design and separate them out so that they can be adapted for two mobile cranes. In the Gantt view, they separate out this stream and reconstrain so that the two streams are overlapping with each other, allowing for the simulation of two mobile cranes at the same time. After completing the fifth scenario, the production engineer can see all 5 of the branches in the Collaborative Lifecycle app from the original template. From a comment in the 3D issue, the project manager can view the fifth scenario and see that there's a 40% time savings if an additional mobile crane is added. In the animation, they can validate the spacing between the mobile cranes and advance it to suggest that this is the scenario to continue developing. The previous scenario is marked as no longer valid because of the clashes that are encountered there. Finally, the 3D issue and the original task are marked as completed to close out this first series of virtual construction scenarios.